Again, I'm Randy Harper, I'm the Regional Manager. Yeah, of Plurus down here in Hampstead, North Carolina. I take care of Eastern North Carolina. We have plants in North Topsail Beach and in Hubert. But we're going to talk about Hampstead this afternoon. I also have our engineer. He came in and sat down with me, Mike Gallant, and he'll start off with what we first designed. At the beginning of the project was built in 2015, and it was a brand new system with a collection system that started off with about 30 customers. So we did struggle. Currently, we're at 1,000 customers, so we're doing a lot better. It's hard to run a 250,000 gallon a day plant with 30 customers on it. So that was a little trying to say the least. But I'm going to give Michael the reins here for a few minutes, and he can talk about what we started with and what his original design was.
So good afternoon. We originally started with microdyne membranes. The footprint for the plant was a 500,000 gallon a day footprint. And we started off with enough membranes to do about half that, 250,000 gallons a day.
Hey guys, I'm sorry to jump in, but just to let you know, what we're seeing is your desktop. We're not actually seeing the PowerPoint.
Oh, all right. Go ahead.
There we go. Now we can see it. Yeah.
Okay. I had it on the external screen. All right. So we'll go back.
Make that a full screen and that slide. Nope.
All right. So there we go. And I'll move this out of the way.
On there. Is there a slideshow button? Or up at the top where there should be something that says slideshow. See at the very top. Slideshow. Okay. All right. So we'll go with this. So we started off with microdyne membranes, 250,000 gallon a day worth. And as Randy said, we started off with a very small flow because it's a brand new system in an area that had not previously had any sewer available in Eastern North Carolina. And we have 2 millimeter fine screens, perforated drum, stainless steel screens, and we are treating with a process with biological nutrient removal. So our phosphorus limit is 2 and our nitrogen limit is 4. So we had to get a pretty good effluent quality out of that. So MBR was the logical choice for that, given our experience. One of the things we started out with, and I heard it mentioned on the previous talk, was the microdyne membranes had a pore size of 0.04 microns. And the Kubotas, I think, have a pore size of 0.4. And so when we first were introduced to the new microdyne membranes at 0.04, I thought, well, that's fantastic because we're going to get that much better filtration. And as the previous gentleman said, that's not necessarily the case. I think there's an issue with that pore size being that tight. And I think there's some technical issues with that and not maybe having it back pulsed or something. I'm not exactly sure, but suffice it to say, within time,
Hey, Randy, we lost your audio. Yeah, you're muted.
Oh, there we go. Can you hear me?
Yep.
Okay. So we were having issues with the membranes, not permeating, not meeting their flux. And so we had the supplier come in and talk to us several times and try to help us out. We could just never seem to get over the hump with them. So after a lot of trial and tribulation, we decided to make a change to the Kubota SP membranes. And one of the things you'll see, like we're looking at this picture right now with these, with the old Microdyne membranes, even when they were shipped to us new, a lot of the membranes seemed like stuck together from either, I don't know if it's static forces or what. And we were told that as you ran them, the air would go between them and they would separate and that would be fine. And I don't know that that was necessarily the case. So we had all kinds of issues with these things. And so the SP membranes are a lot more rigid, and the actual membrane size itself in its structure is smaller. So there's, you're not going to have those membranes hitting each other and touching each other like you did in the Microdyne membrane. So after having a lot of trouble with the Microdynes, we switched to the Kubota membranes and have had pretty good luck with them so far. Even though the pore size is, an order of magnitude greater, we haven't had any problems meeting our nitrogen and phosphorus limits. And we're now running, I think, around how many gallons a day? About 230,000 gallons a day right now. So we're up at the limit of the first phase design, and we're still meeting all our limits with the Kubota membranes. So that's good, and we're excited about that. We've had those membranes in place now for how long?
The new membranes have been in since March.
Since March. Okay, so we'll be coming up on a year this March, and we're hoping that they'll continue to have a good success with them. Membrane plant produces really good effluent, but if the membranes are damaged or falling apart or aren't permeating, that's a real problem. You can't really run the plant that way. And anybody who's an operator who's been through this before knows that if your plant's not running right, the water's still coming through the pipe to your plant, no matter what. So you've got to be able to do something with that water. You've got to be able to treat it and then dispose of it. So it's something that's important to have working properly. We generally try to, when we are looking at a plant for design, usually there's a average daily flow, and then there's a peak hourly flow and things of that nature. And you generally try to size the membrane so you've got a little bit of room so that, if you do get a peak flow or something, you can still pull the water through them and, not have an issue hydraulically. So I'm going to go to the next slide. So Randy and his crew have actually replaced membranes with Kubota membranes more than once. There's another thing we had where they did the similar thing, and they're kind of an old hand at it. They're pretty good at it. And I'm a design engineer, but I'm not at the plant every day. And Randy and his guys are there every day, and they've probably forgotten more about these membranes than I'll ever know. So I'll go ahead and let Randy take it from here. And if you have any questions as far as engineering goes, please feel free to ask.
Thanks, Mike. Again, I just want to point out on some of these slides, you can see some of the separation of the sheets on these, and as well as if you come back into this one here, you can see where the header is. These rings, we had a lot of rips and tears, and there was a lot of rips and tears on the sheets on these as well. This is a brand new membrane. That's how it came to us, but they determined that would be okay. Like Mike said, we finally pulled the trigger. We switched to Kubota. As we did that, they send us everything that you need to do the upgrade. Like you can see the hold down brackets, you can see the Schedule 80 PVC. I have a collection crew that's in-house, so we just did everything ourselves. We just rented a boom truck and a forklift. And you can see this is us wherever we were going replacing. We had to replace this I-beam because the beams were going the other direction. And then we just bolted these in, and then you can see that the guide rails are here. And then you can see the leveling plates in the bottom. All of those were installed. I would recommend though that you, on this stainless steel, I would recommend that you guys, whoever's installing these, that you do this on the outside of the basin, just for any kind of shavings or any material. That's one of our priorities when doing this, is we come back in and we clean this thing with a pressure washer and with a shop vac, because you want to make sure everything is out of that basin before you put those membranes in. The other thing that you have to take into account is you have the telescopic valve that's on one side. You've got to make sure you have enough room for those. The picture on your right shows the updated air header that we had modified. The existing membranes that we took out had 4 diffusers, and then this one only had, the Kubotas only needed 3 because we did a 3-stack unit with the SPs. Here's a picture that shows whenever they delivered them. There's the diffusers, a set of 2, and then there's the membranes that are sealed. I recommend that you just leave that. Protect them the best you can, because that's the life of your MBR basin right there. And you can see that it comes with the lifting tool, which was stated in the first case study that it's very nice to use, very user friendly. These just flop down and connect on, and like I said, we never installed these. It took us a week to pull out the other membranes and install these. The nice part about this facility, it had 2 other trains, so we could keep in operation. So we weren't really under as much pressure. We weren't pumping and hauling like as in the first case study. I would recommend you take off these little wooden blocks before you install them in the basin. You do not have, I didn't have enough room in there. So, but Roscoe, being the magical guy he is, he got them off there for us. So it's very helpful with putting these in. And then got another slide here. This is putting in the levelers, and you can see that these, and then we just put the hydraulic cement around the bottom, and then the diffusers bolt right to the top of these. And then after we got the membranes installed, with it, we put down the hold down brackets, and once those are in, we put the plywood on top to protect the membranes. And then you can see where we have the fabricated permeate headers. The nice part about that is we have a fabrication shop that's probably 10 miles away, so we can get a lot of this stuff done within a reasonable set of amount of time. Again, you can see where the air header was shortened. We took out the one, they just welded in where we had for the 3 diffusers, and then we have the 6 permeate heads. I will tell you, it's a lot nicer to come through. Well, you can see there's where the connection hoses are. Another recommendation that I would have is to put these hoses on to these barbs. We actually had to go and buy a big pot to boil those hoses to get them hot enough to where we could slide them up over those barbs, and then we put the connections in on each one. This is the final product here. But like I said, this is after it's been cleaned. The other, to go back to here, we actually cut out a piece over on the side, and we'll go down about 2 inches, and we'll put in a little 2 horsepower pump. And what that does, 2 things. One, it helps us with this dead area that's underneath the diffusers. No matter however you try to do this, you're still going to have the bottom of that basin. It's not going to suck everything up out of there. So we use that little 2 horsepower pump, and it takes everything off the bottom. And the other use for that is we rescreen that. So anything that gets in that basin, we run it back through our fine screens, which we upgraded from 2 millimeter at North Topsail to a duet screen, it really goes down to a 1 millimeter screen, so it catches everything. That's just another picture that's showing those. Again, right here, and then with these unions that we put in, re-grease them O-rings, make sure that you don't cross-thread those. You have to have the, with the air header, with the heat, we switch those out with the, with the recommendation with Kubota. They recommended the Goodyear hoses. Again, that was with the, just with the 3 diffusers on the bottom because they're dual stacked. You can see after we did the startup, very good with the diffusers. Not really much any dead areas right there. A lot better than what the other ones, the previous ones that we had in. We've cleaned these one time in March, and it's only because we hit our 6 months, so it was we haven't had any problems. We went from cleaning 2 to 3 times a week to cleaning once every 6 months, and we calculated it up that the savings over 3 years will basically pay for the cost of the membranes. We like them so much that we purchased the next 2 basins, and we've also installed another 500,000 gallon unit at North Topsail. With we are waiting on a shipment now to do the other 500,000 in the beginning of next year. So we're definitely all in with these guys. So we're very impressed with the product that they're putting out. We don't really see that there's much issues. I would agree with what's been said today. Very important with operators, and I think your screening is one of the most important things you can do, because once you get something in there, I've seen where something was where they were getting small holes in the side of their membranes, and I would possibly think that that's something that's getting past your screens. And I think that does us for our presentation. If anybody has any questions, they can, like I said, you can get my email. We can go through that part of it. But our permeability went from 3 when we first fired it up, and went from 3 to 99. I'm pretty sure 99 was as high as it would go. We didn't make any changes to the PLC, the HMI, the settings were very minimal. It was kind of like a plug and play. Like I said, it took us a week, and right now we're running 170 at peak through just the one basin. So we're getting ready to do the expansion on the other 2 and the expansion here at North Topsail. That concludes our presentation. If anybody has any questions, just put them in the box there and we'll answer them the best we can. Thank you.